Hello everyone. So on today's session we are going to learn about a solution of system of linear equations using a method called Gauss elimination method. So what the basic concept of this method is going to use, it's going to use the concept of a matrix. So using a concept of a matrix, we are going to find the solution of the linear equations of n number of it. For this problem, we are going to consider three equations. Okay, so how you can make an equation to a matrix form? Just we are going to consider a matrix A, writing the coefficient values of x, y, z from each equation. So when you observe the first equation, we can see the coefficient for x, y, and z as a 1 on 1. That will be the first row of a matrix A. And for the second row, we write the coefficient for x as 1 and y as a -2. Then for z, it is in 3. And the third row, we take the values as its coefficient 2, 1 and -1. This will be a matrix A value. Then we are going to write up another matrix which is called a matrix B, writing the coefficient constants from the three equations. That will be a value 9, 8 and 3. And x is one of a matrix value for the variables of the given x value. Now, you will have a doubt why we have to solve these equations. So, to solve these equations, we will be finding the value for x and finding the value for z and y. So, by solving this, we will get a value for x, y, z. Now, what does Gauss elimination method says? So, we implemented Gauss elimination method. First step, we are going to consider its elemented matrix, defining the matrix values of A and B. So just we take a matrix value 1, 1, minus 1 and 1, minus 2 and 3. Then it is 2, 1 and -1 corresponding to its value 9, 8 and then 3. Now the first step of this matrix is that we have to consider of these three elements, which we call it as an upper triangle matrix. We have to reduce those matrices to a 0, which we call it as an echelon form. So how we can make of these three elements to a 0? We are going to use an row operation. Using a row operation, we can convert an element values to a 0. Let's see how we can do a continuation to it. So now we have to make this value and this value 1 and 2 to a 0. So we can see where it lies. The value of 1 is going to lie in a second row and the value of 2 lies in a third row. So we have to make value of 1 and 2 to a 0 with the reference value of R1. So what should I write the condition now? R2 minus R1. If I apply this condition, 1 minus 1 cannot be a 0. And what should be the condition for an R3? In an R3 we have a 2 and it should be applied with 2 times of R1. So when I apply these two conditions or an operation to it, then we write the value of A is to B. So now what will be the values to it? The first row will be the same as 1, 1, 1 and 9. Second row, use the operation of this or a condition to it. 1 minus 1 will it be a 0? The next minus 2 minus 1 will be at -3. 3 minus 1 will it be at 2? And 8 minus 9 will be at -1. Now for the third row, we use a second operation, that is R3 minus 2 times of R1. 2 minus 2 will it be 0? Then 1 minus 2 will it be a -1? Then -1 minus 2 will it be a -3? And the constant value will be 3 minus 18. It will be a -15. So this is how we make of these two numbers to a 0 using the row operation of applying a particular equation or an operation to it. Now, what is another element which we have to make into a 0? We have to make this -1 to a 0. So now here, continuation to that, let's rewrite of augmented matrix, which was the value 1 1 1 9. Then we have the value 0 minus 3 2 with the constant minus 1. Then 0 minus 1 minus 3 with the value minus 50. This is what the value we have. 0 minus 1 minus 3 and minus 50, 1 1 1 9 and 0 minus 3 2 minus 5. So now let's make of this minus 1 2 and 0. So where it lies, it's going to lie in the third row, which is an R3. Now by making with the reference of R2, we have to make that minus 1 2 and 0. So now what should I write? So can I write 3 times of R3? Will it be a minus 3? Then minus R2. So what will be, let's check, is it a right equation of the operation? R3, okay, we have a value 3 times of an R3, that is 3 times of minus 1 minus of R2, so which is a minus. So this will be a minus 3 plus 3 will be 0. Yes, our operation is right. So now we can use this operation to make minus 1 2 and 0. So let's take a matrix value to it. Then we write 1 1 1 and 9. This will be a 0, minus 3, 2 and minus 1. Now what will be the value? R3 is also 0, R2 is also 0. So this value will be a 0. Now minus 1 into 3 will be minus 3, plus 3 will be 0. And what about minus 3? So this will be a minus 9, minus 2, minus 11. So minus 3. Here we can do the working value 3 into R3, which is a minus 3. The next minus 2. So which is minus 9, minus 2 will be minus 11. The next we can calculate the another 3 into minus 15 minus an R2 value. So minus of minus 1. So this will be 45 plus 1, which is a minus 44. So we have a value as minus 44. So now that's what. See, earlier I have informed you about in the first beginning of it, which are the 3 values we have to make it to as 0? Only the upper triangular matrix, that is 1 2 1 1. So now have we done that? Yes. We have made of these 3 values to have 0. Let's rewrite a matrix in the equation form to that. So which is x plus y plus z equal to 9. From the second it is minus 3y plus 2z equal to minus 1. Then minus 11 of z is equal to minus 44. Now when I simplify this value, what will be the z value? Will be a 4. Yes or no? Then apply this value of z to the second equation, that is if z equal to 4, then minus 3y plus 2z equal to minus 1. So that value will be what? Minus 3y, apply the z as in 4 equal to minus 1. So if you simplify to that, minus 3y equals minus 1. This 4 to 8, if it goes minus 8, minus 3y equals to minus 9, and if you simplify that, y value will be the 3. So from using a value of z, you can find the value for y. Similarly, okay, if y equals to 3 and z equals to 4, if I use of these two values, y as a 3 and z as a 4, then what might be the x value from the equation 1? So x plus, we have an equation x plus y plus z equal to 9. So x plus 3 y value and z is 4 equal to 9. X plus 7 equal to 9 and x will be 9 minus 7 will be a 2. So by this way we are going to write out a value for z, a value for y and a value for x. So hence we can say value for x is an 2, y is an 3 and z is an 4. So now this is how we find variable values for x, y, z. So here there is one more interesting that how can we knowing our values are right or wrong? You can easily verify of the values whether it's right or wrong to it. Just take equation by the given question of any one. So let's we take second equation here, x minus 2y plus 3z, x minus 2y plus 3z equal to 8. So this is the given equation from the question. It is a given equation, right? So let's we take a left hand part of the equation, left hand side, x minus 2y plus 3z. Apply all the three values of x, y, z. So x is what? 2 and y is what? 3 and z is what? 4. So this value will be 2 minus 6 plus 12. So if you do add and subtract to it, what will be the value? 12 plus 2, 14. 14 minus 6, it will be the 8. You will have a value as 8. And what is the right hand side value from the given equation? It is 8. So we have proved that LHS is equal to RHS. Hence we can say what we got the value for x, y, z is absolutely right. Okay, so this is how we are going to prove an LHS equal to an RHS value. So let's take another problem based on the same concept of Gauss elimination method. So now let's have to write a first step with an augmented matrix. Okay, so we all know how to take a matrix A value. So write the coefficients for x, y, z from the equation 1 and from the equation 2 it is 3 minus 1, 2 and from the equation 3 it is 2 minus 2 and 3. And the matrix B value, it will be the constants which are 3, 1 and 2. And the x matrix value will be the given variables in the equation. Those are x, y, z. And we are all knowing what we are going to find here. We will be finding an x value, y value and a value for z. Right? So let's take a value of a should be which is 1, 2 and minus 1, 3, minus 1, 2, then 2, minus 2 and 3. And the value corresponding to that will be 3 and will be a 1 and will be a 2. Okay, fine. So now what we should do? We have to make of these three elements to have 0 using a row operation. So let's try making R2 and R3 to be a 0. So which reference value we are going to take? We are going to take a reference value of R1. So what should be the value for R2? R2 should be R2 minus 3 times of R1. And what should be the value for R3? R3 minus 2 times of R1. So we are going to use an row operation to convert of these two elements to a 0. So now with this we write a value for A to B. So that equals to a value 1, 2, minus 1 and 3. Now what it should be? 3 minus 3 will be 0 and minus 1 minus 6 will be a minus 7. Then the value 2 plus 3 will be a a 5. Then what about the constant? 1 minus 9 will be a minus 8. And apply the value of R3. 2 minus 2 will be a 0. The next minus 2 minus 4 will be minus 6. The next value 3 plus 2, 5. And the last value for the 2 will be 2 minus 6. You have a value of R3 as a 2, then minus 6. 2 minus 6 will be a minus 4. So this is what we actually get a matrix value by using arrow operation for R1, R3. Now which is the remaining term? We have to make minus 6 to a 0 using the reference as R1. So now we have R3 equals, that is R3, then it should be subtracted with R2. So for an R3, we multiply by 7. 7 times of R3 will be a negative value minus 6 times of an R1. Let's check whether our operation is right or wrong. So let's see here on the other side. 7 into R3. What is an R3 value? Minus 6. We have a value minus 6. Minus 6 into, what is the value in R2? It is a minus 7. What is the value for 7 into 6? Which is a minus 42. Minus into minus plus 42. So minus 42 and plus 42 will be the value of 0. Yes. Now our operation or the value what we have considered is right. So let's rewrite augmented matrix to it, which is a value of 1, 2, minus 1 and 3. And the second row will be the same, which is 0, minus 7, 5, then minus 7. See, when you use this operation for an R3, you can see an R3 and R2, both the values are 0. So it will be 0 itself. And when you apply for minus 6, we already proved it will be a 0 because we get a value as minus 42 with plus 42, right? Now, what about the value of this? 5. We write up here 7 into R3, which is what is an R3? 5. Minus 6 into, what is the value in an R2? Again, that is an 5. So 7 5s are 35. And 6 5s are 30. So the remainder is what? 5. So we get a value as 5 here. And we try for the constant now. So we are trying here for each numbers to it. So 7 into minus 4, right? Then minus 6 into R2, which is often minus 8. So which is a minus 28. Minus into minus plus, which is a 48, correct? Now, when you do a subtract to it, it will be the plus 20, the value will be plus 20. So, we write the value here, it's going to be a plus 20. So, now, what we have made already, we have to make a minus 3 plus 3 plus 2 and minus 2 to a 0. We have made of those 3 values are 0, that's the end of it, converting to an echelon form. Now we make a matrix to an equation form. So what can we write? So we can write it as x plus 2y minus z equal to an 3. And the second row will be a second equation, which is minus 7y plus 5z minus 7y plus 5z equals to a minus 8. And the third row value will be in equation 3, 5z equal to 20. When you solve the equation number 3, which is 5z equal to 20, you will get a z value as 4. So by using a value of z z equals to 4 and applying for the second equation, minus 5y plus 5 into z equals to minus 8. So minus 7 into y plus 5 into 4 equal to minus 8 minus 7y equals minus 8 minus 20. Minus 7 into y equal to minus 28. That will be y is equal to 4. Right? So you will get, when you apply with the division, minus 28 by minus 7, you will get a value as 4. Now, using y value and value of z and applying to the first equation, which is x plus 2y minus z equal to 3. So let's see what will be the value for x. X plus 2 into 4 minus 4 equals to 3. So x, so 8 minus 4 will be the 3. So x plus 4 equal to 3 and x will be 3 minus 4. So we write x value as minus 1. So by this way we are going to know a value for x as minus 1, value for y as in 4 and value for z is also in 4. So by this way you will be finding the value for x for z. If you want to know about your solution is right or wrong, you can go with the verification step. Just take any equation from the given question to you. Okay, if you take the first equation, that is x plus 2y minus z is equal to 3, right? X plus 2y minus z equal to 3. Now, take the left hand side, apply of these values, x as a minus 1 plus 2 into y as a 4 and minus z as a 4. So this will be a minus 1 plus 8 minus 4. So this will be a value of minus 5 plus 8. What will be the remainder? It will be the 3. So is it equal to the RHS value? Yes, it is. It's going to be equal to an RHS. Hence we can say LHS is equal to the RHS. Thank you.